Okay, welcome to another Orbiter Spaceflight Simulator video. And in this video, I'm going to be using Orbiter 2010. I was hoping to do this video with Orbiter 2015 beta, but for the type of flight that I'm doing here, I was having a little bit of trouble getting through the flight without having Orbiter crash on me. So I'm going to just revert back to Orbiter 2010 for this video. I'm also going to try to record this video at 60 frames per second. The last time I tried to do this, YouTube completely mangled the video, so we'll see if it works out this time. Let me go ahead and switch camera views here. And what we're going to be doing, what I'm going to be doing in this video, is taking the Shuttle A back to Earth, but you'll note that I have these cargo containers on the Shuttle A. This is one of the default scenarios that comes with Orbiter 2010 by default. It's in the Shuttle A folder, and I think it's just called Shuttle A on the Moon. Now, the particular description given for this mission, or for this scenario, says that you're going to basically take the Shuttle A back to Earth, drop these containers off in the Indian Ocean, and then return the Shuttle A back to the Moon. I don't know if I'll necessarily do a round trip, we'll see. But at the very least, I want to do the cargo transport part of the mission because I thought that sounded fun. I don't think I'm going to target the Indian Ocean though. I think I would rather target right off the coast of Cape Canaveral, so that's probably what I'm going to do. Let's jump inside the Shuttle A and get our MFDs configured. So let me press F8 to get over to this view. I've always been bothered by the fact that that part of the building has some weird graphical glitch. I wish I knew how to fix that, because the rest of it's obviously stable, so there's just something with that texture. Anyway, in order to target a specific point on the Earth, I find that really the only way I know how to do it is to use interplanetary MFD. If I use Transx, I have to basically do at least 2 or 3 practice flights ahead of time to find out where the how the planet's going to basically be rotated by the time I get back to the Earth. It's very unsatisfying to do that, and it just comes down to the fact that Transx doesn't have sort of the longitude, latitude predictions that the interplanetary MFD has. So I'm going to use this MFD for this purpose. And I actually had to go back and re-watch my IMFD training video that I did with Dimitri earlier this year just to remember how to do this, because it's been so long since I've used interplanetary MFD, and I've actually never used it to go from the moon back to the Earth except for the time that I did that video with him. But I think I've got it pretty well under control now. So I'm going to start by obviously bringing up interplanetary on this side. I can go through this pretty quickly now. I'm going to hit the menu button to bring up my list of options. And I'm going to bring up the base approach program. Then I'm going to reference the Earth. And I'm going to page over to get this other set of options, and I'm going to set my source as the moon. Now, since I'm not going to be landing on Earth, the Shuttle A obviously isn't built for atmospheric reentry, so I'm not going to be doing a reentry, which means I don't need to come in here and set a landing target because I'm not going to be landing. At least I don't think this is necessary. So instead, I'm going to page back over to get to the other options. I'm going to change the type of approach for orbit insert, which basically gets rid of my other option, which the way I did this with Dimitri was to basically come to the hint, and we would add in enough time on the hint to basically give interplanetary MFD an idea of how quickly we wanted to get back to the Earth. And I noted that when I changed over to orbit insert, that option's gone, so don't have to worry about it. With orbit insert, it does give me an idea of where I will end up at on Earth with regards to my latitude and longitude, and by default it is 00, which is right off the coast of Africa. So now I'm going to bring up map MFD, and I'm going to reference Earth, and so 00, that's there, and that's not what I want. So that would be 30 degrees west. Let me think if that's right, 60 degrees west. Let me target Cape Canaveral real quick just to make sure I'm thinking correctly. Yeah, so that's 0, so that's 30 west, that's 60 west, that's 90 west, so Cape Canaveral is 80 west. So let me zoom in on Cape Canaveral on track. And what I'm saying that I want to do, like my vision of success for this flight is going to be to dump basically have the cargo re-enter, and it's going to land somewhere off the coast of Florida. Now, to me, in fact, it might even be cooler to put it in the Gulf, but to me, success looks like this. If the cargo hits on land, it's a failure. That's in my version of this flight. I'm going to say that if it hits anywhere on land, it's a failure. I would like it to hit off the coast of Florida, but I don't want it to be like way out in the Atlantic Ocean. So let me get an idea of my latitude and longitude. So that's 80 degrees west, so maybe 84, 85 degrees should be out in the ocean, I'm guessing. So let me start with that. That's going to be my longitude. I can probably do an adjustment here. Yeah, so let's go the other way though. So we're going to say, okay, 80, again, 80 west is still on land. Now this, of course, setting the longitude here doesn't necessarily mean that's exactly where the cargo is going to land, because you have to remember the cargo is just it's just like dead weight that's going to be going down through the atmosphere. It doesn't have any attitude hold, it doesn't hold an AOA, it doesn't have wings or anything like that. So I really don't have any way to control exactly where it lands. So the best I can do is just kind of set a coordinate and hope for the best. Alright, so that's going to be 81 west, which should be like right off the coast. Now I need to set the latitude, which I'm going to say, so 28 degrees. We'll just go straight. We'll use the same latitude as Cape Canaveral. 28. And then go down to a 1x adjustment, and we'll go 28.5. So let me think about this for a second. Now I also want to set my target altitude for like something low. Do an adjustment here. Actually, go all the way to 100 because I'm going down a lot. So I'm going to set my target altitude down to like 40 kilometers. Now, I'm not actually going to re-enter with the Shuttle A at 40 kilometers because obviously this thing would incinerate. So what I'll actually do is once I'm on my way back to Earth, because I'm carrying the cargo, everything's attached with me. But once I get close to the Earth, then I'll detach the cargo. It will continue on its trajectory, and then I'll raise the orbit for the Shuttle A, so the Shuttle A won't actually hit the atmosphere, but the cargo will continue on its trajectory. So let me just think about this for a second. 81 degrees west. Now, the other thing I'm not 100% sure of. Okay, so if my altitude... What I'm trying to think of here is I want the cargo to land out here. So if it hits, let's say the cargo hits entry interface at that latitude and longitude, then it's going to continue going for thousands, or hundreds of kilometers. So I wonder if I actually need to back up the longitude by, quite a bit so that it hits entry interface up here somewhere and then, comes down through the atmosphere. That's what I'm not completely sure of. So let me back up the longitude a little bit. Let's back it up to 90. That hopefully that's not too much. Yeah, 90 seems like a bit much. So let me try 86. That's just kind of an arbitrary figure, but I'm thinking that the cargo, if I set the longitude right around Cape Canaveral, then it's going to, the cargo is obviously, it's going to come down through the atmosphere and it's going to pass by. So I really don't know. We'll just have to fly it and find out. So that's going to be it for that setup. There's really nothing more I can do in terms of making my flight more efficient, I don't think. Yeah, because I can't control these options here, so I can't get in, and play with the fiddly bits as some people have worded it. So that's it. I'm done with base approach. Now I'm going to go menu, and I want to say, yeah, surface launch. Now surface launch defaults to be connected to the course program. I'm not using the course program. I'm using base approach. So I'm going to hit plus to make it connect to that program. Change the projection. Now it's telling me that I need to lift up off the landing pad here and rotate to 65 degrees and head out. So that's what I'm going to do. That's really about it for the setup. It's quite simple. There's maybe a couple more things I could take into consideration, but that's really the main thing right there. So let's go ahead and get underway. I'm going to apply a lot of hover because this is a lot heavier than the standard Delta glider, so it takes more hover to get it up off the ground. Let me bring up orbit on this side, change the projection, change the distance. All right, here we go. Raise the skids.
Translate rotation.
And I'm going to rotate around to 65.79, so we're right just before 66 degrees. So that's 66, about right there. That's 60, that's 70, so 65 is right there in the middle. 66 would be right there, and I want to be just past it, which I am. I've also noticed as I've been playing around with Orbiter 2015 beta that it's no longer good enough, at least in Orbiter 2015, to hover up off the landing pad and then immediately apply thrust, because I've managed to crash into the mountains around the moon several times. So it's actually not a bad idea to apply a lot of hover and get up. Now, again, this is 2010, so it doesn't matter, but in preparation for Orbiter 2015, it's not a bad idea to start hovering up much higher than you normally would for orbiters. So highest peak on the moon is it's just under 11 kilometers, so somewhere around maybe 6 or 7 kilometers, then you can apply your thrust because you'll continue climbing. So right about now is good. Full power on the main, lock it. Now start removing hover and pretty much immediately pitch back a little bit. Not a lot, just want to make sure, again, the velocity vector stays well above the horizon. And in this case, it would be no problem. I'm already at 9 kilometers and climbing, so I'm just going to go level on the horizon. But I've actually, in taking off in Orbiter 2015 and doing it the way I would normally do on the moon, which is to just get up off the pad and then go straight to the main engine, I've actually managed to hit mountains on the moon a couple times. It's kind of funny to do that. Now, I don't want to lose altitude, so as that velocity vector drops, I will make sure that I'm staying above the horizon. I also want to watch my EIN. That's sort of like your relative inclination, just to make sure that it's coming down. I want it to be 0.00 by the time all is said and done. It's coming down quite nicely, so I'm not going to do any adjustments right now with regards to my yaw, because I still have to gain another 1,000 meters a second, and at the rate that's coming down, it looks like we're pretty good. Maybe just a touch of rotation one way or the other to figure out which way I will need to rotate. Okay, looks like about that way, so. Okay, go ahead and lock the level horizon again. And you can see my apoapsis is all the way up to 25 kilometers. I actually wasn't paying, I think I should have set my altitude here. When you do surface launch, this is basically telling the surface launch program how high I want my altitude to be once I get into lunar orbit, and I would usually never have it that high, so I should have set that, but it's not terribly important. I've talked to Dimitri about that, and he's told me that it really doesn't make much difference. So just a touch of rotation there to try to get that last 0.01 on the relative inclination. Now, if I wanted to, I could kill my thrust now and then go ahead and go up to apoapsis and circularize, but I'm just going to go ahead and let it continue. Relative inclination is down to 0, so I just want to keep an eye on that to make sure it doesn't start increasing in the other direction. We're almost at orbital velocity, so I'll be killing the engines here in just a moment. And we'll go something like that. I went ahead and let it go a bit higher than I normally would, mainly just for the fact that I never bothered to change that to what it should be set. Relative inclination went out by 1 1,000th, but that's such a insignificant number you don't even want to mess with thinking about it. We have to do other adjustments later in a flight anyway, so it's just not even worth thinking about. Now we're done. I'm done with the surface launch program, so I can go to menu, and now I want to go to orbit eject. And again, it will be, let me think about this for a second. Yeah, by default, it's connected to this higher orbit program, which I'm not using, so I want to come around and make sure that it's looking for its information from base approach. And the projection thing, completely optional. I just don't like to see sideways projections, so I'll go hit the projection button. What I'm looking for here is I want to know, am I going to reach the ejection point before I reach apoapsis or after? Well, since I'm orbiting around this way, I'm going to reach apoapsis first, so I'm going to want to circularize my orbit. So it's just good to know that information, because sometimes, as I've talked about in other videos, if I were taking off like from here and reaching the ejection point there, then I wouldn't even need to bother to circularize. But in this case, I need to. So let me warp time forward over to the high point. And I can manually circularize, or I can use IMFD to do it. This doesn't make a lot of difference. Go ahead and go to the prograde position because I'm only 200 seconds out. Give the autopilot time to settle. I guess since I'm in the IMFD mindset, we can go ahead and use IMFD to circularize. I think there's a couple of ways to do it. You can do the orbit circularize, but I think you can also do course. Not orbit insert. That's definitely not what I want. I guess maybe orbital is the only way to do it. I was thinking there was a couple of ways to do it. So I also want to do, I can't remember if I do auto burn, because I think if I do auto burn, I think it starts burning right away. So let me get closer to apoapsis, because I need to be, I have 38 seconds of burn time. Let's see, no, 4 seconds or 3.5 seconds of burn time. So basically when I'm 1.5 seconds from the apoapsis, then I would circularize. So let me get really close to that time. See, I know burn time calculator will actually wait till you reach apoapsis until it circularizes, but for some reason I'm thinking this program starts burning as soon as you hit AB. Can't remember 100% though. Turn off prograde though. Get into the proper position. And auto burn. Yeah, I think, I'm pretty sure it just does the burn as soon as you hit the button. Okay, there we are. We're basically circular, or we are circular. The eccentricity is down to 0. So done with that. Back to the orbit eject program. And now I want to begin my plan for heading back to the Earth and dropping off this cargo. But I'm at about a little under 20 minutes on this part of the video, so I'm going to go ahead and end this part of the video here, and when we come back I will complete the sort of the ejection burn to head back to Earth, and then some point along the way, when I get close to Earth, I'm going to separate the cargo from the vessel so that it continues on its trajectory toward the target, and then I will raise the orbit of the Shuttle A so that it doesn't hit the atmosphere. If you like this part of the video, hit the like button, and if you didn't like it, that's okay, hit the don't like button. Check for links in the description down below, and I will see you in the next part. Target right off the coast of Cape Canaveral, so that's probably what I'm going to do. Let's jump inside the Shuttle A and get our MFDs configured. So let me press F8 to get over to this view. I've always been bothered by the fact that that part of the building has some weird graphical glitch. I wish I knew how to fix that, because I have these cargo containers on the Shuttle A. This is one of the default scenarios that comes with Orbiter 2010 by default. It's in the Shuttle A folder, and I think it's just called Shuttle A on the Moon. Now, the particular description given for this mission, or for this scenario, says that you're going to basically take the Shuttle A back to Earth, Okay, welcome to another Orbiter Spaceflight Simulator video. And in this video, I'm going to be using Orbiter 2010. I was hoping to do this video with Orbiter 2015 beta, but for the type of flight that I'm doing here, I was having a little bit of trouble getting through the flight without having Orbiter crash on me. So I'm going to just revert back to Orbiter 2010 for this video. I'm also going to try to record this video at 60 frames per second. The last time I tried to do this, YouTube completely mangled the video, so we'll see if it works out this time. Let me go ahead and switch camera views here. And what we're going to be doing, what I'm going to be doing in this video, is taking the Shuttle A back to Earth, but you'll note that drop these containers off in the Indian Ocean and then return the Shuttle A back to the moon. I don't know if I'll necessarily do a round trip, we'll see. But at the very least, I want to do the cargo transport part of the mission because I thought that sounded fun. I don't think I'm going to target the Indian Ocean though. I think I would rather